Hello, it's nice to see you again, my good brothers. In Mr. Tanfax's space exploration video series, do you know which is the highest mountain in the universe? Did you know? Even though the sun is big, it's still just average in the world of stars. Or is it really the number of stars in the universe? More than grains of sand on all the beaches in the world. Welcome to Brain-Shattering Facts Part 2. Scary facts about the universe 4. The skin under the heel. It's the hardest and thickest part of the human body as a lifestyle adaptation, moving with our 2 feet. However, on the International Space Station, the Earth's gravity, it's working on astronauts almost zero. As a consequence of this space station, and the astronauts inside it are constantly in free fall around the Earth at about 7.66 kilometers per second, forming the microgravity environment inside. So that astronauts, instead of walking around, will float and fly. To move between the compartments of the space station, the skin under their heels, after 2 to 3 months not used, will soften and flake off into large patches. Like this. Not yet. Water is one of them. Precious resources in outer space. It's also become more difficult to do laundry. The alien team will have to wear a constant stream of underwear and socks for many days. And when you take them off, they have to do this as gently and slowly as possible. If you don't want to, every pound of dead skin, scabies and lice will be with them, flying everywhere in microgravity environment. For this interesting, it's easy to talk about microgravity because of this phenomenon that your height will increase dramatically with a maximum of about more than 5 centimeters in space, where the skeletal and cartilage systems no longer have to carry the burden, the weight of the body. In addition to that, you can still cry, but you've lost the ability to cry, where tears instead of falling. It's a big lump around the eye, like this. Talk about mountains. While Everest is the highest mountain on Earth, at 8,848 meters above sea level, the Mauna Kea in Hawaii, again the highest mountain on Earth, from the base of the mountain to the top of the mountain with about 10,000 meters, of which only 4,207 meters is above sea level. A little further away, Mount Olympus on Mars. It's a mountain on a planet, highest in the solar system, at 21,287 meters above the Martian standard line. Unlike the 25 kilometers figure, compared to the average surface of Mars, which is the height from foot to tip, calculated through measurement, change in height from the lowest point to the highest point in the area, and rarely used. Still in the solar system, Mount Vesuvius is located on the asteroid vector of the asteroid belt between the orbits of Mars and Jupiter, with a diameter of about 525 kilometers. In an informal and still controversial way, it's the highest mountain that humans have ever recorded in space at about 22,000 meters. The Sun is the largest object in the solar system, with 109 times the diameter. The equatorial circumference is 109 times, 12,000 times the surface area, 330,000 times the volume, and 1,300,000 times the volume of the Earth. To make it easy for you to imagine, if the Sun were an empty sphere, we can fit about 1.3 million Earths inside. That's it. The Sun is still a star, air of medium size, or even being listed as G-type dwarfs, with the common name of the yellow dwarf. Speaking of dwarfs, by the way, so this is a common name for stars that are relatively small in size and low brightness. It should also be noted that, say a star is relatively small, which means it's relatively small compared to larger stars, rather than being small in the usual way. For example, EBLMJ055557 OV, the smallest star ever discovered. It's still 112,000 kilometers in diameter. It's 8.8 times the diameter of the Earth, slightly better than Saturn. It's the second largest planet and 80% the diameter of Jupiter. the largest planet in the solar system, at a completely opposite extreme. The largest star in the known part of the universe was discovered by humans. By diameter as of 2019, UY Scuti or BD1-5055, with approximately folded diameter 1.708 times the diameter of the Sun. That's about 2,374 billion kilometers. To make it easy for you to imagine, Scuti is more than half the size of the solar system. With the width of the solar system here is the average distance from the Sun to the longest planet Neptune, 4.495 billion kilometers. And to go radial, from one end of the universe's largest star to the other, you're going to need 2,710 years. If you're driving a car at 100 kilometers per hour, or 2 hours and 11 minutes at the speed of light, approximately 300,000 kilometers per second, you can walk on Earth, Mars, or the Moon, simply because on these planets and satellites, there's solid surfaces for you to walk on, which means you can't walk, or even standing on Jupiter, Saturn, Uranus, and Neptune, because they're all gas planets. It's made mostly of gases. Of course, of these, Jupiter and Saturn are giant planets. It's made mostly of hydrogen and helium, and Uranus and Neptune are giant planets. It's made up of elements heavier than hydrogen and helium. It's oxygen, carbon, nitrogen, and sulfur. To talk about the crowding of stars in the universe, people often have a sentence like this: the number of stars in the universe, more than grains of sand, of all the beaches on Earth. The word seems so indifferent, and that lack of scientific validation turned out to be amazingly accurate. More specifically, scientists estimate that each galaxy, a large system of stars, the stellar remnants, the stellar environment of dust, gas, and dark matter, it's about 100 billion stars on average, plus the number of galaxies in the observable portion of the universe. According to the latest announcement in 2016, about 1 trillion galaxies, we have the number of stars in the observable part of the universe. It's about to by 10 to the power of 23 stars. In the same way, by evenly dividing the size, grains of sand on Earth, calculate the number of grains of sand in a given range, multiply by the number of beaches, and the deserts of the planet. People get it. The Earth's relatively precise number of grains of sand, it's about 7.5 by 10 to the power of 18 particles. From this, it can be concluded that the number of stars in the universe, more grains of sand on the beach, and the deserts of the Earth. Not only that, that's a lot more, about 26,666 times more. There is an undeniable truth that the Earth's climate is becoming increasingly extreme. But even if it's extreme a few more times, then we should still be grateful to God to live on Earth, not on the following planets. In the atmosphere of Jupiter, there's a high-pressure area called the Great Red Spot, where the cyclone spawns. It's the largest in the solar system, with a width of about 16,350 kilometers, 1.3 times the diameter of the Earth, with winds that are already 618 kilometers per hour, about 1.5 times more. The strongest wind ever recorded on Earth, at 408 kilometers per hour. It was recorded during Hurricane Olympia in the 4th of October, 1966, in Barrow Island, Australia. It's worth mentioning that the superstorm on Jupiter, it is believed to have existed as late as 1665. It was first discovered to this day. That's 354 years. Mercury owns temperature deviation into the most terrible line, solar system, with an amplitude of over 600 degrees Celsius at about 430 degrees Celsius during the day, and minus 180 degrees at night, enough to constantly bake you during the day, freezing at night, and then thaw again, and roast again the next day. The most important thing to mention, it's these countercyclonic storms that are in the Big Black Spot, or the Great Dark Spot on Neptune. Even though it's only about the size of the Earth, that's a little smaller. Compared to Jupiter's Great Red Spot, the wind in the Great Dark Spot reaches its limit, about 2,400 kilometers per hour. And at the same time, the most terrible winds once recorded in the solar system. To make it easy for you to imagine, the cruise speed of a jet airliner, Boeing 747, it's about 920 kilometers per hour, or the speed of sound in the air, It's 1,234.8 kilometers per hour. It's the fastest in the solar system. It's because astronomers recently has discovered the winds. The fastest in the universe are essentially ultraviolet winds, or UV wind, as they swirl around a supermassive black hole at about 200,000 kilometers per hour. That's about 20% of the speed of light. However, it's also important to note that the last super wind has a completely different nature compared to the winds of the Earth or from planets in the solar system, which is intrinsic, are the flow of gases. Ultraviolet wind, along with many other cosmic winds, are essentially streams of energy. For example, plasma jets from the sun, which we call the solar wind, or movement at extremely high speed of the gas on the accretion disks around the quasars. It's called the quasar wind. That's it. Now, are you still complaining about the weather? Hi, nice to see you again. The universe is vast. No one disputes this. So these interesting facts about the universe, it's also countless. But in today's video, we'll just bring it to you. The most terrifying dark corners that you'd be hard-pressed to find on any other channel. Welcome to the Scary Facts About the Universe 5. Before getting to the main content, consider subscribing to the channel and share this video with friends to motivate Mr. 10 Facts to do another video. The galaxies are being gnawed. The galaxy, our own galaxy, and hundreds of other nearby galaxies are being eaten by something unknown, bigger than anything that people have known in the universe. Really, in 2009, a group of scientists discovered a group of galaxies is moving at an incredible speed in an unusual orbit towards the part of the sky between the two constellations, Centaurus and Velar. As usual, when there's something big and have the ability to strongly attract other entities, people will immediately think of black holes. However, even the largest black hole ever discovered, with about 66 billion times the mass, solar mass, it's called the Ton 618. It's still too small compared to what the scientists were looking for this time, and they named this bizarre phenomenon dark flow. In relation to those, another mystery of the universe, like dark matter or dark energy, still according to which the entity is supposed to be knowing hundreds of galaxies in the universe, including our own homes. It's called supermassive black hole and is defined as a distinct gravitational anomaly that's in intergalactic space. At the center of the supercluster Laniakea, where our world is registering a permanent address and is supposed to. There is volume, thousands of times the mass of the Milky Way. So in the end, what is a supermassive black hole? And how does that relate to dark matter or dark energy? I don't know. My father doesn't know. And scientists don't know yet. Wandering black hole. 2017 Hubble Space Telescope has located a supermassive black hole. It's about 1 billion solar masses and potentially escape from its galaxy to travel aimlessly through the universe at 8 million kilometers per hour. The scary thing is, this supermassive black hole, just the way our planet is, it's 8 billion light years. That's about 76 by 10 to the power of 21 kilometers. And if it keeps going in the direction of the Earth and pedaling, then it seems that humanity will be extinct in just 1.08 billion years. Are you scared? Scarce resources. It is not right to say scarcity, because water is one of those resources, the most abundant on Earth, with a quality of about 1.386 billion cubic kilometers. Enough to make a round lump of water. It's about 1,385 kilometers in diameter, with about 3% of that, for 1,580,000 cubic kilometers, is fresh water. So at a distance of about 400 kilometers above our heads, whether the water is sweet or salty, it's also a very expensive thing. And so the astronauts on the International Space Station will never enjoy the sight of the cradle to cradle, as under our world, plus the cost of shipping water or any other equipment up to low Earth orbit, with altitudes ranging from 160 to 2,000 kilometers. It's still too high. Ranges from 1 for 000 to 000 USD 1 kilogram. So since 2010, astronauts will be reused. Water that's recycled from sweat itself, urine, and their own domestic wastewater. It's like having a special system. In fact, the machines on the space station can recycle up to 93% of the water it takes in, mainly sweat and urine. The processing lasts up to 8 days. Will produce a liquid, more pure, most of the water that we use every day. Notice that NASA says that. United States Air and Space Administration also said one of their astronauts drank 730L of pure water, filtered from the impure, during my 1-year journey. And now you've got one more vivid example for the concept of the water cycle. Sound in the universe. Space is an eerie, silent place, but there are also areas where intergalactic dust clouds exist so densely that they can travel like sound waves. Of course, the volume is still only at the same level that the human ear cannot hear. Besides the sound in the universe, it also exists in the form electromagnetic vibrations, and it's moving in waves. In fact, NASA, well, it's actually exploration ships, or NASA's satellites, ever recorded those electromagnetic vibrations. And this is what people get when trying to convert them to sound. The Sun Man. If we define a person living inside the Earth's atmosphere, the people of Earth, and one who lives inside the Sun's atmosphere, it's the Sun Man. Then me, you, and all of us. They're all solar people. And if you're wondering, does the Sun have an atmosphere? Yes, please. There are many more. According to Wikipedia, people define the atmosphere is a class or a collection of gas classes around a planet or another solid object and is held back by the object's gravity. Even though the Sun exists in a plasma and not a solid, but people still recognize the existence of solar atmosphere with 4 layers: the chromosphere, transition region, corona, and finally the heliosphere. But they define the heliosphere is a region of space, is bubble-shaped, dominated by the Sun, and spread across the orbit of Pluto. Inside the heliosphere, plasma that's blown out from the Sun in the form of solar winds to form and maintain an invisible shield, protecting all the planets in the solar system from the pressure of the interstellar environment. The interstellar environment, and now you can be proud, it's the Sun Man. The sudden deaths. With the current level of science and technology, NASA was able to predict, and predictable, the orbits of asteroids, and asteroids are large enough to be able to cause global catastrophes. And that means, in the near future, humanity in general won't have to worry about sudden deaths too. However, each individual needs to worry about your own life, because there hasn't been any organization or individual to have a technology can predict the dangers from small asteroids. As the explosion cost, it's about 400 to 500 kilotons in the sky over the city of Chelyabinsk, the Russian Federation in February 2013. That's about 26 to 33 times. Atomic bomb Little Boy, BE dropped Hiroshima August 1945. It's also important to note that the Chelyabinsk meteorite, only 20 meters in diameter, it weighs about 13,000 tons. The sad ending. Nothing can last forever. Boring lessons, your first love and the universe. Now there are 3 big theories, and get the high consensus of the scientific community about the end of the universe. That's the Big Crunch theory, a spherical description of the universe that will shrink back to the size of the universe's origin singularity, with extreme heat and freezing. The Big Freeze. Describe the saddle-shaped universe, permanent expansion and cooling until it approaches absolute zero, the temperature of death, and finally the Big Rip. Simulation of the universe in a flat form, and will continue to expand at an ever-increasing rate until all matter is torn to one level that only Ant-Man know.
You could go sub it. Go sub it up. Oh no.
However, in all 3 events, if it really happens, we won't have a chance to see. So, let's talk about something closer and more intimate. That's right, the end of the world. And it's not what you think. It's not nuclear war. It's not super meteorites. It's not a super epidemic, the rise of artificial intelligence, or the decommissioning of the giant emulator called the universe, but the sun itself, the life of the Earth, that will destroy the Earth in the future, in a certain way, not just hypothetically. Accordingly, every second of fusion reactions or nuclear fusion in the core of the sun will consume about 5 million tons of hydrogen to cook helium and solar radiation. And at the current rate of combustion, the solar furnace will soon run out of wood. The Earth and mankind will die long before that could happen. Still with it, it's been calculated that every billion years, the sun's brightness will increase by about 10%, which means that the Earth's average surface temperature in the year 1,000,2018 will fall to about 70 degrees Celsius, killing most of the plant toxins, of course, humans. And likewise, about the year 2,000,2018, all the water on Earth would disappear. That our green planet, to what Mercury looks like now. And if you think that's the worst, not yet. About 5.4 billion years from now, the sun will use up all of its hydrogen, and it swells into a red giant star, devouring the innermost planets, like Mercury, Venus, and possibly the Earth as well. Eventually, the red giant will die, removing the heavy layers of clothing to form a planetary nebula. The core is constricting to form a white dwarf star. It's about the size of our planet right now. White dwarf star will continue to shine for a few trillion years, and then it gets cold, become a black dwarf star, sinking into the silent darkness of the universe. This is also seen as the moment it marks the death of the sun. And if you're expecting, no, our star doesn't have enough mass to create a supernova explosion before becoming a white dwarf. Hello, I'm very happy for seeing you again in Mr. Tanfak's Universe video series. Space science is a vast and complex field. The people who made this video without training or have expertise in space science. So, we're always trying to bring to our audience interesting and useful information as accurately as possible. Welcome to the scary facts. But maybe it's not so scary about the P6 universe, pocket black hole. How wide is the universe? When asked about the universe, the first word most people say will be vast or infinite. How big is the universe? And is it really infinite or not? Not everyone knows. And according to the most genius minds of the most intelligent living thing in the universe, more precisely the part of the observable universe, it's about 93 billion light years across. And with a light year is the distance that light can travel in a vacuum, has an approximate value, 9.500 billion kilometers. 93 billion light years would be equivalent to about 883,500 by 10 to the power of 18 kilometers. It sounds so bad. At the current level of human science and technology, we can go all the way from here to the other end of the universe in just 300,000 billion years on the Helios B, the fastest spacecraft as recorded in human history, at 252,792 kilometers per hour. That's about 70 kilometers per second. Under the condition, the universe has a constant size over time. We fly from one end to the other. That's because 883,500 by 10 to the power of 18 kilometers, only relative and temporary. When the universe, by the time you see this video, is constantly expanding at speeds faster than the speed of light, which we'll probably talk about in more detail later. And if you drop the observed part, the true size of the universe, it's still a problem that no one can claim at the present time. Intergalactic war. It's basically the relentless expansion of the universe, that the galaxies are moving apart. Many observed galaxies are even moving away from our galaxy faster than the speed of light, and that means, most likely, we'll no longer see these galaxies. In the future, because of the light that comes from them, we'll never be able to reach the Earth. And if this is the case, that's making you wonder, because it violates one of the fundamental laws of physics, that nothing is possible traveling faster than the speed of light. Not really. The galaxies themselves can't move itself faster than light. The universe, more precisely, the space itself of the universe, is constantly expanding at speeds greater than the speed of light. That pushes galaxies in the universe apart. Go back to the galaxies. While most are drifting apart, the Milky Way, our home galaxy, and Andromeda, a neighboring galaxy, are getting closer and closer together. At about 110 kilometers per hour, it's predicted to collide in just 4 billion years. In fact, it's basically integration of the two galaxies mentioned above. It's quite peaceful, or what we might call a bloodless merger. The collision of two stars together. In this union is said to be rare, or it's almost impossible to happen. Because even though the number of member stars comes from two galaxies, up to 1.3 trillion, with about 1 trillion coming from Andromeda, and 300 billion come from the Milky Way, but the distance between them is also enormous. Take the nearest star to us, for example. It's 4.5 light from the Sun. To make it easy for you to imagine, if the Sun were the size of a ping pong ball, Proxima Centauri will be about 1,100 kilometers from that ping pong ball. And then, the diameter of the Milky Way would be approximately 30,000 kilometers. And as the density of the ping pong balls increases at the centers of galaxies, but the two ping pong balls are on average 3.2 kilometers apart, or to stars with an average distance of 160 billion kilometers. Collision is almost impossible. Of course, peace is always just part of the picture. Even if it's not destroyed by a direct collision, countless stars will be shot out of the newly formed supergalaxy over the course of millions of years of two supermassive black holes before they merge to form a quasar or galactic nucleus, operating and releasing a tremendous amount of energy that's equivalent to about 100 million supernova explosions. Another interesting piece of information, it's during the process that our galaxy and the neighbor merged. There's going to be a young man called Triangulum Galaxy, watching from beginning to end, and it's predicted that we'll be able to continue to merge with newly formed galaxies. It's called Milkomeda or Milkdrometer. Pocket black hole. In a simple and straightforward way, black hole is a region in spacetime that the gravitational field is so strong that it blocks everything, even the light, the fastest thing the universe has ever recorded, can't get out. To say light is the fastest thing the universe has ever recorded, it's because the scientists are fumbling. The theory of a subatomic particle, it's called tachyon, traveling faster than the speed of light, back to the black hole. In terms of size, they've divided black holes into 3 main categories, including supermassive black holes. With controversial origins, it's usually found in the center of most galaxies in the universe. Stellar black hole. It's the black holes formed from the self-collapse of massive stars, with the smallest volume, 20 times the mass of the sun. And the last one is the primordial black hole, a hypothetical kind of black hole with a magnetic mass smaller than the mass of the sun, to approximately the mass of a human egg. And because it's so small, this kind of mini black hole can only be formed naturally in extremely dense and heterogeneous environments in the early stages of the universe, immediately after the Big Bang expansion. And when I say can only be formed naturally, which means scientifically speaking, can produce artificial black holes, based on a theory called the Schwarzschild radius. Accordingly, the Schwarzschild radius describes the limit radius, that if the size of the object is compressed less than this value, it's going to become a black hole. To make it easy for you to imagine, the sun can immediately becomes a black hole if we have a machine that's big enough and powerful enough to compress it into a sphere approximately 5.9 kilometers in diameter. It's the same. The radius of the Earth as a black hole is 8.87 millimeters, and the moon's 0.11 millimeters. Talk a little bit more broadly. Whatever has mass in the universe, it's also possible to become a black hole, as long as we have a powerful file compression software, which continues to raise questions. If one day, the emphasis is that one day, when people are really capable creating artificial black holes, what would happen if a black hole happened is the size of a peanut suddenly appear in your pocket? Let's see. You have to first determine the black thing in your pocket. What is nature? A black hole collapsed from a peanut-sized object, or a black hole the size of a peanut. In the first case, the black hole that you think is going to be horrible, only the atomic scale, and will disappear in less than a trillionth of a second, thanks to a phenomenon called Hawking radiation. It's true that even light can't escape from black holes, but these mysterious entities of the universe themselves is said to be constantly emitting the thermal electronic radiation, degrades energy and their own mass.
Warning, Hawking radiation detected.
Scientists call it black hole evaporation. The smaller the black holes are, the faster it disappears. And along with the black hole, you also disappear, because it's been calculated that for every gram lost, the amount of Hawking radiation coming out of the black hole equal to the destructive power of approximately 10,000 tons of TNT explosives. That's 2/3 of the explosion of a little boy. It was dropped on Hiroshima in August 1945. It didn't stop there. If that black thing in your pocket is about the size of a peanut, that means you're carrying the whole Earth, with a mass of about 5.97 to by 10 to the power of 18 tons on its own. You will die this way for sure, and still as above, death will come so fast that you won't even notice. Worse, Earth and more than 7.6 billion other people in the world will also die with you.